Okay, so let's go ahead and finish up these examples of like cross section. And again, these last two, I'm noticing both are going to be perpendicular to the y-axis. And when they're perpendicular to the y-axis, again, just as kind of to reiterate this, when you're perpendicular to the y-axis, things are going to be in terms of y, and you're going to be measuring your, I guess, your typical cross section from right to left. And again, just, we could see this just on a head view of looking at R from right to left. Each time I measure that, I'm in between two particular functions. Okay. Now, you can, I think on the last example, I didn't draw it as a perspective drawing, but you can certainly draw it as a perspective drawing on the y-axis as well, when you're perpendicular to the y-axis. To me, it's not as natural, and so I don't like it as much, but that's okay. We can work with that. So I'm thinking about 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and up 1, 2, 3, 4. 1, 2, 3, 4. So like this corner over here, if I think about like that spot right there, that's 5, 4, which corresponds to this guy right there. And since it's perpendicular to the y-axis, remember we're going to be focusing on the y value is part of our bound. The other one is -1, -2. So -1, -2. And even my tick marks I'm trying to draw at that perspective. So here's the -1, -2. There's this point right there. And so then, we just do our best and no judgment, definitely. Please don't judge mine. And we'll draw that base. So connect here, go through there and that point right there. And then it looks like I have 1, 2, 3. That might be a good spot. 1, 2, 3. To know that I need to kind of swing out to here, kind of swoop out, and then connect. So again, trying to draw R kind of flat. So here's R flat on the ground, right? I just had a thought here. What if I go to this crayon? I know it sounds silly, but if I go to the crayon, I don't know why this makes me kind of think, okay, so here's the base. Yeah, that's fun. Just having so much fun today. So there's the base of our solid. So then we go back to our pen. And again, we think, okay, we're measuring things right to left, and we're going to create a semicircle. So if I go from this point to this point, kind of just going across there, whatever that distance is, I'm going to create a semicircle. And whatever this distance is, I'm going to create a semicircle. Whatever this distance is, I'm going to create a semicircle. So again, I'm starting to see this three-dimensional shape coming off the page. Maybe it's the Sydney Opera House, who knows? But the key is that as you measure from right to left, this height or this figure becomes a semicircle, like that one right there. And that might be a good one to kind of take a look at. So remember, semicircles have an area. If an area of a normal circle is pi r squared, a semicircle is half of that. So we could think pi r squared over 2. And this happened in the last example too. Remember, when we are measuring this distance here, when we're measuring this distance across, that's not the radius of the circle. That's the diameter of the circle. So when I do right minus left, I've got to remember that that's the diameter. So I just have to make sure I keep track that this divide by 2 is because it's a semicircle. I'm going to have another divide by 2 somewhere because this distance here that I'm going to be measuring is actually the diameter of this particular semicircle. Okay, so we integrate. So we're going to go from the lowest y value, which is -2, to the highest y value of 4. Because again, thinking about these, these these semicircles, like they're building from the lowest y to the highest y. Lowest y being -2, highest y being 4. Lowest y being -2, highest y up here being +4. And they are semicircles. So I don't know, we'll just switch colors, make it super colorful. So semicircles is 1/2 pi r squared, and it's in terms of y. And then this pi over 2, so -2 to 4, pi over 2. And remember, how are we getting our radiuses? Well, we're doing the right minus the left. The right, which is the linear function, which I forgot, that function is y plus 1. And I'm saying function, but I should say curve. Y plus 1 minus, and then, so that's the right side minus the left side. And that one was, oh yeah, we had to fix that. We had to make it y squared minus 3, or 1/2, I'm sorry, y squared minus 3 for the parabola. So 1/2 y squared minus 3. Now, remember, that distance is just the diameter, so I have to divide that whole thing by 2 and then square it, because that's our characteristic formula for a semicircle. And again, just to reiterate, like this divide by 2 is because we're doing a half a circle, semicircle. This divide by 2 is because we were first given the diameter, right? This measurement here is the diameter, divide by 2, and then we square it. And I probably would clean that up just slightly. Oops, I could find the pen. So dividing by 2 and squaring that, I could make that a 4, and there's a pi over 2, so I could make that an 8 if I wanted to. I could say -2 to 4. I could throw that pi over 8 in front if I wanted to. And then I could just say it's y plus 1 minus 1/2 y squared minus 3 as a quantity squared dy. And I might even just leave it like this. And I'm thinking about that only because, again, it really illustrates the fact that I have a right side minus the left, right? Like I have the right side minus the left side, and that would have been the diameter. So we have one more example. Again, feel free, pause the video. Maybe you can try to set up the next one and then check it out, see what happens. But I'll go ahead and solve this one as well. And again, similar situation. I think it's the exact same geometric three-dimensional shape. Each rectangle's height is twice the base. And so again, the base would be measuring from right to left. Right to left. So if I want to think about, getting that nice image down there again, just drawing that out. And again, you could be like, well, why is this video taking so long? Well, part of it's because I'm, trying to draw a somewhat of an accurate sketch. And again, I think I said this on a previous video, you don't have to be an artist on the AP exam. You just have to sort of make sure you understand the order of what's happening. So 1, 2, 3, 4, 5, 4. 1, 2, 3, 4, 5, and then 1, 2, 3, 4. Ooh, that's a little bad. It's okay. We'll go right there. And then -1, -2. -1, -2. So here we go. And then I liked that key point, this key point out here of -3, 0. 1, 2, 3. So I know that I'm going to start here at -1, -2, go through, I think we said we also go through this point there. I'll choose red. I realize that early in the morning, my voice sounds a little groggy, apologize. And we'll just go ahead and make that arc. Swoop out. Maybe not as good as the last one, but that's okay. And then we go ahead and make rectangles. And again, measuring it from the right side to the left, whatever that distance is, I'm going to go twice as tall up. So whatever this distance is, this is a longer distance here. So whatever that is, if it's 10, then I've got to go 20 up. Okay, so that, so we kind of get that idea. So maybe I'll make a tiny one back here, or a smaller one. Again, I think I admitted it. I'm not as good when it's perpendicular to the y-axis as I am to the x. And I feel guilty. There's your x-axis, there's your y. So now things are labeled. Okay, so let's take a look at that. Maybe that rectangle, maybe this one right here. Right, so we're looking at that one, and we're looking at the base times the height. And so I know I'm perpendicular to the y-axis, so I know that I have to be things in terms of y. So I'm going to integrate from the lowest y of -2, which is here. Remember, this point was 5, 4, because that point was 5, 4, up to 4. So negative 2 to 4, and it's the base is twice the height. So it's just base times the height in terms of just rectangles, right? Remember, this formula is area of a rectangle. So now I have negative 2 to 4 of base, and the height is twice the base. So now I have something that's just going to be in terms of the base, which is perfect because that's what my two equations are. So now I'm going to scoot over just this way. Negative 2 to 4 of 2b squared in terms of y. Not really sure where this random mark is. Try to erase it. There we go. So 2b squared. It just likes to be there. Okay. And then again, thinking about where that base comes from, you're measuring things right to left. Right side to left side. So the right side of the curve, I believe, was y plus 1. So negative 2 to 4. Put my 2 out front. So it's y plus 1 minus 1/2 y squared minus 3. So that represents a base, and then I'm squaring it, and it's in terms of y. And certainly leave that 2 out there. Now, you could leave it. Like, this is perfectly fine and acceptable on the AP exam. Like, that would be great. You don't necessarily have to distribute that negative. If you see there's a negative here that could be distributed, you could do that. You don't have to. But here's the thing. Here's what you should not do. You cannot distribute the square. In other words, you cannot do this. I'll even write it in like red, like not valid or equal. Okay, you can't do y plus 1 squared minus 1/2 y squared minus 3 squared. Okay, the squares don't distribute like that. And I know, just looking at old exams, if this were a multiple choice type of question, this becomes a really good distractor, because we're going to see in the next unit that some of our volume formulas might have this structure. Some of them might have an r squared minus an r squared. And so that's kind of like leading into our next topic. But if it's just a volume of a rectangle base times height, you do not distribute that. So please make sure you don't do that. I'm going to erase that. So I don't want anyone to like log in and say, oh my gosh, what is Mr. Brown teaching here? So that is not valid, not valid, not valid. I guess I got it erased, but it's okay. So there it is. There's our final answer. So again, hopefully this makes sense. I think what I might do is create maybe a couple more videos on some of the worked out warm-ups or examples, just in case you want to see some more. And if there seems to be like a common homework question, then I might certainly work through one of those. Just because, again, this is a tough topic, and you got to remember that you're learning this, via, online and just a video tutorial. So do your best, and then we'll continue to work on the next section.